Welcome back everyone, Patrick here, and in this next video what we got to do is we got to take these four expressions here and rationalize the denominator. So starting with number one, we got 5 over 4 root x. This one is pretty simple. What you do is multiply this by root x over root x. Basically when they're saying rationalize the denominator, we want to get rid of any sort of square root in the denominator. So if we want to get rid of this square root x, we got to multiply by another square root x, because then those two multiplied is going to give us x, but we can't just multiply the denominator by that, we've got to multiply the numerator by that same expression. So it's like we're taking this, multiplying it by 1, so we're keeping it the same, we're just adding more onto it. And then what happens here, 5 times root x, that doesn't simplify to anything, and then we have this 4 here, and then root x times root x gives us x. Right, so this expression, when we rationalize the denominator, we end up with that right there. Notice there's no more square roots left. Now, number 2, we got 1 over the third root of x. So this one's going to be a little bit different. You got to be careful, because you might think what you got to do is multiply this by the third root of x over the third root of x, right? Like we did up here. The problem is that the third root of x times the third root of x, that's not going to give us x. So the third root of x, we could rewrite that as x to the power 1 over 3. We multiply it by another x to the power 1 over 3. We could add those exponents, and we would have x to the power of 2 over 3, which would give us the third root of x squared. So notice that that third root is still there. We're actually going to have to multiply it again by the third root of x over the third root of x. We've got to multiply it 3 times, because then if we go back to here, we'll have x to the power 1 over 3 times x to the power 1 over 3 times x to the power of 1 over 3. And then when we add those exponents up, we would end up with x to the power of 3 over 3, which is just x to the power of 1, which is just x. Right? So here, because there's like an imaginary 2 over here, we only had to multiply another one here. So square root of x times square root of x gives us x. But the third root of x, we have to multiply it 3 times in order to get that x by itself. Right? And so now we would have third root of x times third root of x times third root of x. That gives us x. And then over here we have 1 times third root of x times third root of x. Now these two, we already did that on this side, but I'll write it again. This ends up being x to the power of 2 over 3, which ends up being the third root of x squared. So we would have the third root of x squared up there, like that. So this here is the final answer, right? This and this are the exact same thing. If you plug in any x value into this or into that, you'd get the same answer. It's just now we don't have any square roots or any kind of roots, any third roots in the denominator. Same thing here, we have the fourth root of x. So what we're going to have to do, multiply this by the fourth root of x over the fourth root of x times the fourth root of x over the fourth root of x. And then we got 1, 2, 3, so we're going to have to multiply another one. Right? So now we'll have the fourth root of x multiplied 4 times by itself. That would finally give us x in the bottom. But then we'll have the fourth root of x multiplied 3 times. So we'll have x to the power 1 over 4 times x to the power 1 over 4 times x to the power 1 over 4, which would give us x to the power of 3 over 4, which would be the fourth root of x to the 3. So this would end up being the fourth root of x to the 3. Like that. That's how we rationalize that. This and this are the exact same thing. Notice there's no more roots in the denominator. And then if we look at this pattern, we can sort of generalize it for the nth root of x. And if you notice, basically what ends up happening is we get x at the bottom each time, and we end up getting that third root or that fourth root up top, but then we have x to the power of 3 over here, which is 1 less than 4, and then 2 over here, which is 1 less than 3. So if we generalize this, basically we would end up with the nth root of x to the power of n minus 1, like that. Right? So this here is basically, in general, how we rationalize an nth root. So you could apply this to anything. If we have 1 over the 10th root of x, well, to rationalize this, if we plug in 10, notice the n is 10 in this case, so we'd have 10th root of x to the 9 over x, like that. This and this are the exact same thing. If you plug in any x value and it's rationalized, we rationalize the denominator because we only have an x left at the bottom. All right, so that's how you rationalize denominators, where we've done examples with square roots, but sometimes you can have larger roots in the denominators, and that's how you deal with them.